So this is basically a review for 3.8 through 3.10. And again, these are just the ones I selected that were most frequently missed. It might not have been the one you missed, but it's the one that I saw more than maybe 1 or 2 people missed. You know what I'm saying? All right. So I'm going to start with the first one I want to cover, and that is, in the first section it says, find the range of each function given the domain and the rule, and then graph it. So this one says f of x, x squared plus 1, and it gave us a domain of -2, -1, 0, and 1. Okay? So my favorite way of doing these, and I don't know if you all like doing it this way, is to plot a little chart. And I kind of give up using the f of x terminology because this is just the way I do it. In the middle, I put the rule, and then I start figuring out my values. So I've got 4 points. I've got -2, -1, 0, and 1. To solve, I plug each one in for x and see what I get for y. So -2 squared, what do you get? Hopefully you get a 1, right? So that means this point is 2, 5. The next one, -1 squared is 1. I get a 2, meaning that I end up with -1, 2. 0 squared is 0. And that gives me 0, 1. And the last one is 1 squared plus 1, leaving me with a final set of coordinates of 1, 2. So as we continue, this video will be available later for you to look at. So we're going to keep on going. The graph that I want to show you guys involving these points is take the x coordinate and the y coordinate. -2, 1, 2, 3, 4, 5. -1, 2, 0, 1, and over 1 up 2. Should look something like that. Okay, that's the beginning of this particular graph. Any questions on this one? Okay, these are kind of easy. The next two, several of you missed. This is where they ask you, give the domain. Okay, so they give you a function and they say, what's the domain? Now think about what domain means. Domain is what values can I use for x? Okay, so the one for number 6 is f of x is x plus 7. Instead of thinking, what can I use, I want you to think, what can't you use? What number can you use for x to make this nonsense? There isn't any. So the answer to this one is going to be all real numbers. Okay? This one is simply saying you can put anything in here and come up with a y value. Negative 957 million? Yeah. Well, I would have a y value of negative whatever I just said. I forgot. Okay? Anything can work here. In contrast, number 7 is something like this. What can I have for a domain of g of x equaling 3x plus 1? Well, what can't I have? What can't I have? The only thing that can't happen is I can't divide by a 0, right? And this is a division problem, 3 divided by this sum. Therefore, if my divisor cannot equal 0, then anything that causes this to be a 0 is nonsense. Agreed? What x value would cause this to be a 0? -1. That means the answer for this, the domain can be all reals, but not a -1. Or you might have put all except -1. okay? Because a negative 1 added to a positive 1 is 0. And 3 divided by 0 is what? There's no y value that means that. Not even 0. You can't take 3 and divide it into 0 groups. But yeah, it's kind of one of those things that doesn't exist, okay? The next section, a few of you kind of hit and missed here. So again, you probably didn't miss all of these, but you might have missed some. This question is, find an equation of the linear function using the given information. So find an equation. If they tell me the f value at 0 is 1, and they tell me the output increases by 12 when x increases by 3. Okay? First, let's get a handle on what that is. If I tell you f of 0 equals 1, does 1 give me any huge piece of information? Do you guys remember? Y-intercept. If your x value is 0, then that means this is your y-intercept. So I'm going to start plugging in my equation. F of x equals mx plus b. There's my y-intercept. So I have my b. Okay? I would like to find my slope. Over here I've got the output goes up by 12 when the input goes up by 3. So the output changes by 12 when the input changes by 3. That's your slope. That's telling you how much stuff changes. That's your m value. Okay? So now I can plug in my m value. There's your answer. Okay? So if you have a 0 for x, the y is your b. If you have an increase in output compared to the increase in input or change, don't think of it just as increase, it could be change, that is indicative of your slope. Okay? And that gets plugged in here. What if you're not given information like that? What if you're given, so here's another one, a slope of 6 and a pair of points like this? Okay, if I'm given a slope and a pair of points, I can use my slope and my points to solve for b, and then use b and m to create my equation. It would look like this. This is my input, this is my output, right? This is my x, this is my y. So my output is equal to my slope times my input plus b, right? There's my m value, this is input, this is output. If I subtract 6 times 1, which is 6 from both sides, I get a -1 for b. So now I have a b value and I have an m value. All I got to do is plug them in. F of x equals 6x minus 1, because it's a -1, okay? You don't have to write plus -1. Okay? So this case, I was given a slope and a point. Here's another one. What if I am only given points? Like this next one. Okay? I'm given points. Can I find slope? Once I find slope, can I backtrack and find b like I did in the one above? Okay, let's find slope. I'm going to go this way. So change in output, -6 minus 3, over change in input. So you should have -9, -3, otherwise known as a positive 3. Would you agree? So positive 3, this is my slope. Okay? Now, which pair of points do we want to use with our slope? I'm going to use this top one because wherever there's a 1, it's just less of a challenge to multiply. So, y equals mx plus b. Okay? 3 equals 3 plus b. Subtract 3 from both sides. 0 equals b. Okay? Therefore, my equation is f of x equals 3x plus 0. You don't have to write the plus 0. Okay? 3x plus 0. This literally means that if I were to sketch this line, the y-intercept is right at the origin. Okay? Right at the origin. If you did, however, write the 0, I certainly didn't mark you wrong for that. Okay? But it's standard operating procedure to just write it like that. Okay? All right. Graph each relation and tell me whether or not it's a function. If it's not a function, draw a vertical line to verify that the thing intersects at more than one spot. Okay. Use some of my handy dandy graph paper, which several of you used, and I really appreciated that. Made it easy for me. All right. This graph paper is just so small. So we're going to do the first one. Over 2, up 1. So that's 2, 1. Over 0, up 0. So I'm going to make that 0, 0 just for my own. And then negative 1, 2. Negative 1, 1, 2. Okay? This is what you have. You have 3 whopping points. Is this a function? It sure is, because there are no lines that I can draw that make this, that prove that this is not a function. Okay? How about this next one? Negative 2, 1. Negative 2, 1. Negative 2, 1. 0, 1. And 2, 1. Is this a function? It sure is. It is. Okay? You cannot draw any line down to show that it's not a function. Okay? How about this one? Negative 2, 2. So this is negative 2, 2. Negative 1, 2. Whoops, that should be here, but negative 1, 2. I can't see this. That's why I'm making new paper. Negative 1, 2. 0, 1. And negative 2, 1. Uh-oh. Negative 2, 1. Okay, we have negative 2 having a relationship with both 2 and 1. This is no. The vertical line test shows us that this is not a function. Okay? All right. The last 2 that I have for you. Flip to another sheet of paper here. Hang on one second. Just want to make sure that's there.